Welcome in a third section of our course. In this section, we'll be focusing on image processing problem and we'll be solving it using RNN deep learning techniques. So let's see what we'll look into in this section. So the first video will be about analyzing input video data and data pre-generation. So we'll be trying to understand the input data that we will be analyzing in deep learning neural network. Then we'll be achieving image processing classification with neural network. So we'll try to create a neural network that will be able to classify our images. Third video will be about leveraging state of previously processed data with RNN. So we'll be applying RNN techniques to make our algorithm work better. Fourth video will be about cross-validation of the deep learning model. So once we will create our model, we want to validate its accuracy and precision. Finally, we'll be tweaking our image processing model. So this is a first video in which we'll be analyzing input video data and the data pre-generation. So we'll be leveraging MNIST database. This is a database with digits that are handwritten and could be served as an input to deep learning algorithms to learn those algorithms how to classify them. So we'll be understanding classification problem and we'll be doing classification of frames. So those frames will be our MNIST images with the digits on it. So this is a simplification of MNIST database and it looks like this. So we have some handwritten digits. If you see those squares with purple color, in a real data set, it will be a handwritten digit. So for example, 5 written by a specific person and that data is pre-labeled. So it means that we can use it while doing training. So we will have a 5 as a data and also label 5 as a number integer. So leveraging that, we will be able to learn our model, teach model how to treat, for example, handwritten digits 5s. And then when new digit that is not labeled will arrive to our model, we'll be able to guess which number it is. So MNIST dataset has numbers from 0 to 9, so every handwritten digit. So let's understand classification problem and how can we solve our image processing of handwritten digits. So at the left hand side of this picture, this diagram, we have our handwritten digits. So let's say that this is an input and that input is a feature vector that we'll be putting into our network. So we will feed that into network. We will create a deep learning neural network, we will perform a training, and then our neural network will be able to classify zeros, handwritten zeros, as the actual 0 number, then 1 as the actual 1 number. What's important, at the left hand side of this diagram, those numbers are in fact images. So for our human eyes, it can be perceived as a number, but for the computer program, it is just an image, so those are bits of data and they are not actual number in the context of, for example, integer or floating point number. So we need to find out a way to transform those images that are at the left hand side of the picture to the proper classes. So we'll be classifying them into 10 classes, 0, 1, 2, up to 9. Every number will have own class.